All right, let's go ahead and do the word problem here. Mrs. Langeli is 17 years older than Eponine. Lily, Mrs. Langeli's daughter, is 12 years younger than Eponine. The product of their ages is 2,890. What are their ages? So let's go ahead and call me X. So X can represent Mrs. L. Okay, so I see that I am 17 years older than Eponine. So you know what I'll do? How about I give myself that extra 17 since I'm 17 years older than her. And for Eponine, let's give her just X. So now it says Mrs. Langeli is 17 older than Eponine. Let's take a look at Lily, my daughter. My daughter is 12 younger than Eponine. So I take Eponine and I subtract 12, I will have my daughter. The word product right here means multiply. So it says the product of their ages. So I'm going to take my age, X plus 17. I will multiply it by Eponine's age of X, and I will multiply that by Lily's age of X minus 12. And I see the product of their ages is 2,890. I missed the word is there, but I'll get it in there on your paper before I print it. So just like everything else that we've been doing today, we're going to set this equal to 0. And we're going to use your calculator to see where it crosses the x-axis. You don't need to distribute that together if you don't want to. I mean, you can if you want to. You don't need to. Your calculator can handle it. So we're just going to keep it x plus 17 since we're going to use your calculator to see where it crosses the x-axis. And set it equal to 0. So if I grab my calculator, type it in, I have x plus 17 times x minus 12. And then that really big minus 2890. When I hit graph, I'm not going to see the graph at all. It's kind of a problem. Well, the reason is because we're trying to solve for Eponine's age, and this only goes to 10. So if I hit my window, and why don't we go to 20? Let's see if Eponine is 20. She's not 10 years old, but I'm going to guess she's before 20. So if I hit graph, I'm going to see if I can see now where it crosses. There it is. So if this is 20, this is 19, this is 18, this is 17. So it appears that it looks like on the graph, X crosses at 17. That means that's Eponine's age because she was X. Well, if that's Eponine, then X plus 17 is 34. That's Mrs. Langeli's age. And X minus 12, so 17 minus 12 would be, I can subtract, 5. That's Lily's age. All right, so those are the ages because we looked and see where it crossed the x-axis. I am going to tack the got-its onto this paper. If you want to wait to do the got-its in class, if that was an option I gave to you, go ahead and take that option if that was an option I gave to you. I did not give that option to everyone. All right, so we're going to go back and we're going to take a look at the got-it for type 1 GCF, and it does not factor. Okay, so I need to step 1, set it equal to 0. So move the 2x cubed to the other side, put it in order with our 14x squared, and then the minus 8x, and then set it equal to 0. Step 2, my GCF is 2x. Everything has a 2, everything has an x. So I will get x squared plus 7x minus 4 when I divide by 2x. Step 3, I'm going to realize that this does not factor. The reason this does not factor is because nothing multiplies to negative 4 and adds to positive 7, which means I'm going to have to use my quadratic formula. Now the first part of the problem is easy. You just take 2x and you set 2x equal to 0. Then you divide by 2 and you get 0. So one of my answers is 0. And I'm going to take a moment and put this on my calculator. I'm going to get my normal graph back, go to my y equals, and I'm going to take out my old equation and put in my original 2x to the third power plus 14x squared minus 8x. I'm going to take a look at my graph. Sure enough, my graph does cross at 0. It looks like it's going to cross over here as well. So it's going to cross here at 0 and somewhere else. So I do have my 0 solution. To find the other solutions, I need to do the quadratic formula. So I'm going to do negative b plus or minus square root of b squared minus 4. A is 1 since we took the GCF out. And C is -4 since we took the GCF out, times 2 times A is 1 again. So that's -7 plus or minus the square root of, let me cheat because I did this on my other paper already. You end up getting 65 all over 2. There are no squares inside of 65. So these are your other two answers. And where the graph is crossing, those must be the decimal forms of my answer. So my other two answers are -7 plus the square root of 65 over 2 and -7 minus the square root of 65 all over 2. There are no imaginary solutions. And you should have recognized right here, please point at the exponent of 3. It should have had 3 solutions. I did that problem very fast. If you need to pause it or slow it down, please do so. Got it, number 2. This is going to be a GCF, and it does factor. So let's take a look. Step 1, set it equal to 0. X to the 4th plus 3x squared minus 4 equals 0. Step 2, I'm going to notice there's no, in this case, there actually is no GCF. I mean, I guess technically it would be 1, but I'm not going to sit here and pull out a 1. I can do that all day. Step 3, I am going to try to factor it. And if I can't factor it, I'm out of luck because I cannot do the quadratic formula because that's not a quadratic. So hopefully this does factor. Let's take a look at factoring this thing. And I'm going to factor it over here if you want to draw an arrow. So my A times my C is -4. And I needed to add to 3. So my numbers are 4 and -1. So when I draw my factoring box, or if you do factoring by grouping, that's perfectly fine. You're going to put x to the 4th here. You're going to put a -4 here. You're going to put a 4x squared and a -1x squared. That's hard for kids. We're using an x squared because look at where I'm pointing with my pencil. We're using an x squared because of that. Now you're going to find GCF, so x squared minus 1. And again, x squared, what's this one going to be? Plus 4. So those are my two things that I get when I factor. So I'm going to put those over here. X squared plus 4, x squared minus 1. And then I'm going to set each thing equal to 0. So the first one and the second one. On this one, I'm going to subtract 4. On this one, I'm going to add 1. On this one, I'm going to take the square root. And I get positive and negative. The square root of 4 is 2. And the negative becomes an I. So those are imaginary answers. And over here, I'm also going to take the square root. And I get positive and -1. No imaginary answers. Now if I put this in my calculator, let's see, what was it? The root x to the 4th plus 3x squared minus 4. When I graph it, I should see that it crosses at positive and -1 because of these answers. And then I should see that these are the only places where it crosses because it's not imaginary. So the real answers are positive and -1, and the imaginary answers are positive and -2i. All right, so if all else fails, like on the test, if you get stuck, you can at least put it in your calculator and see where it crosses, and that will at least give you your real solutions. It won't give you your imaginary solutions, but it will give you the real solutions. Let's see if I can get type 3 done here. Let's see, difference of perfect squares. Let's take a look at these perfect squares. Oh, I like these. So step 1, set it equal to 0. I'm just going to put that there because it is equal to 0. Step 2, please notice there's no GCF. Step 3, we're going to factor this because it's the difference of perfect squares. I can do it pretty quickly just by doing the square root of 25 is 5. The square root of 36 is 6. And the square root of x squared is just x and x. So 5x plus 6, 5x minus 6, as we've learned before. And this is going to be, only 2 solutions. I hope you see this only has 2 solutions because of the x squared. And I like these solutions. These are going to be easier solutions than they have been in the past. 5x plus 6 equals 0. 5x equals -6. X equals -6 over 5. When you divide, there's one solution. And the other solution, 5x minus 6 equals 0. Add the 6. 5x equals +6 instead of negative. Divide by 5, we get +6 over 5. So I have 2 solutions. I have +6 over 5 and -6 over 5. And if you put it in your calculator, take a look. You can, I hope you're starting to see like the ability that your calculator has to help you like kind of manipulate these equations. Sure enough, there it is crossing at -6 over 5 and +6 over 5. If you really want to go further, you could check them by typing them in and seeing that you do in fact get 0. That could be extremely beneficial on a multiple choice test. It's the ones that give you 0 that are your answers. All right, let's get this. Got it. Number 4, difference of perfect cubes. Now this one's your new one. All right, so let's set this thing equal to 0. I don't like this big negative over here, so I'm going to add 6x cubed and subtract 5. So when I do that, I get 0 equals, this is for step 1, a positive 8x cubed, because you're combining your like terms, and a positive 27. This is new, and it is something you're going to need to be able to visualize. These are perfect cubes. Okay, so this one is the sum of perfect cubes. We're going to follow this format up here, and I will walk you through it step by step. So if you can recognize you have perfect cubes, you're going to have a small parenthesis. Oh, by the way, there is no GCF. I should